Okay, starting from last time, we generated our path curves, and the first thing we're going to do is to detail our terrain using these paths. So to do that, I'm going to fetch back the terrain first. So I'm going to add a file sub, and I'm going back to the top to see. Just a second. There we go. Yes. So this is the cache that we want to fetch after we transformed the terrain using the water. So I'm just going to copy parameter and paste relative references. And now we should actually have the same terrain here again. Sorry. So file post water from cache. And because, so now we want to transfer this, and we could transfer it in 3D, but in that case, there might be some small variations. Like if you're doing the transform on a slope, you might get a slightly different result than on a flat area. I think I might as well demonstrate that. So the first thing we're going to do is give some attributes to our curves. So I'm going to add a wrangle node for that. So we're going to say road is a float attribute and it's equal to 1. And we make a color attribute which is equal to CHV, which is a channel vector. And we'll call it road color. There we go. And now we can again click the create spare parameters button. And because we set it to CHV, it will generate a vector for us. In our case, we actually prefer to make it a color. So we can just go to the drop down and select color instead. So now we can use our color picker to make some kind of road color, something like this. So let's use an attribute transfer, and we transfer onto our terrain our new road curves. And now it will just do that like that. But we actually want to control the width of our road. So what I'm going to say is that our roads are going to be 2 meters wide and a fall of another 2 meters. So right now we just transferred the color, but we also want to transfer the height because we want to flatten the roads a little bit. So let's do that. Elevation equals vp.y. And now we actually, we do need to create the elevation here too, because otherwise it might actually already exist, but just to be sure. So if we say vp.y equals elevation, so right now we're only having the elevation on the left side. So everywhere where it's not transferred, there is no existing elevation. So to fix that, we're going to add this node. Okay, there we go. So now we actually have a road. We still have some interesting stepping artifacts. And that is because right now it only takes the closest sample. But we actually want to take a couple of the closest samples and use a weighted transfer. Attribute transfer actually has something built into this, which is the kernel function. So we're just going to set the sample count to 4, so the 4 closest points, and then it will magic some value that is proportional to the distance of the sample points that it found. I think we probably also want to decrease the radius of the kernel, because we only really are interested in stuff that's within the direct radius. And now we actually start to see that, yeah, the road is more or less smooth now. Okay, so there's 2 more things. Right now, if I add a color node and I say ram from attribute road, it probably will say completely white. Oh, no, it actually already works. Okay. Oh, yeah, because the default value will be 0 anyway. But just to make sure that that works, we'll just say road equals 0 here. Ah, yes. Yeah, so you actually saw the difference. You can see that the blend only works if the attribute exists on both sides of the attribute transfer. In our case, we actually might want to just move this to the left so we don't cross the wires. Okay. So let's just demonstrate the difference between 2D and 3D. So I'm going to add a null node, put the render flag on it, and hold Control and click on lock. You might get a pop-up. No, wait, you might get a pop-up when you undo that. But don't worry about that. So now I have this, and wait. Oh yeah, because I switched the direction, sure. So let's move all the positions down. And because we stored the elevation, we can also do that on the left side. So now everything is flattened and transferred. And then when we set the elevation back, we should still have the right result. Okay, so let's see the difference. Yeah, you can see that basically the road becomes less wide if the slope is steep, because the amount of points that it can sample is slightly less in 3D space than in 2D space, if that makes sense. Basically, the road path curve is further away from the points in 3D than in 2D, because there's some distance in the Y as well. But when we flatten that, there's no issue with that. So all our roads are nice and flat. Okay, so there is one last thing we want to add here, and that is actually exclude transferring over the water. So let's do that too. So what we're actually going to do here is use another attribute transfer and transfer onto the roads from the terrain. And we're going to transfer the water attribute. And also here we can actually specify that we want to not do any primitives, but we do want to transfer the color. Oh, not P. Set color, the elevation, and the road attribute. Okay, so now it will not look at all the other ones. And here we can just do the water one. Okay, and what we can do then is just use an polycut. And we can just say if water is larger than 0.1, remove. Yes, so now you can see there are some cuts in the curves. So let's preview that. Yeah, well, in this case, the path actually goes through a stream, which is not ideal, I would say. But yeah, you can see the difference. Yeah, here it makes a bit more sense. So you could later build a bridge to accommodate for the gap in the road. Okay, store information. Okay, so let's add a facets hub, because right now the new normals of the roads are not yet applied. Or at least it didn't recompute the normals yet, so let's do that. There we go. So now the roads are smooth as well. Move it a little bit. So let's make it look nice. And let's copy paste this. And let's name it Terrain Post Paths. And there might be some old, yes, old paths, but we're going to save the disk. There we go. And now it's our new paths. Okay, on to the final part of this tutorial. Okay. Yeah, okay. So let's actually create some rocks and some trees to put on our terrain. I'm going to make very simple trees, but they should be easy to just replace later. So let's go make a deciduous tree. I'm going to be very rudimentary. 0.2. I'm just going to extract the channels. 0.6. Add a tube. No, wait, not like that. Like this. And let's add a merge. We probably don't want to use any primitives, but actual polygons. Oh, let's do that. And there we go. Yeah, okay, let's actually make it a bit like that. So now we have like the most basic shape of a tree. Let's add some color. Constant. Let's make that part green. this white brown. Okay, let's simplify the geometry a little bit. That should be enough. Set facets up. There we go. And the next part will actually save these to disk and actually place them. But for now, I'm just going to continue by building a rock, I think. Oh wait, no, let's first do a pine tree as well. So let's copy paste that, get rid of that, add another tube, put it on polygon again, put the radius of that like that, that like that, and put up the shape a little bit. Let's move down the radius scale. Oh yeah, that doesn't really work. So as long as the ratio is about right, it's okay. And then move down a little bit again. And I'll add just a couple of rows. And I'll add end caps. And I'll add a divide. No, not a dissolve. A divide sub. And disable maximum edges. Now that doesn't work. Let's put it on 4. So now we have a nice squat at the bottom as well. Okay, there we go. And now we just want to create some rocks as well. And I'll go for a bit of a cliff type. So let's start with the box. So I'm going to put it into the Y direction. So let's make it 25, 1.5 in the height, and 1 in this direction. So we have a nice rectangular box. And we want to set it to a polygon mesh. And we want to make sure that we have an even distribution. There we go. Now I want to smooth the corners a little bit because that will become too obvious when we put them down as instances. So let's add a wrangle node. And what I'm just going to do is deform it using the Y distance from the center. So vector rel boss equals rel point dbox. And we're going to just use the first input and the current position. And I'm just going to scale the x. So dot x times equals, well, let's just do rel plus y first to see what it does. So now it should create a triangular shape that looks like this, I think. Yeah. Because basically right now it's negative here, positive there, and the further away from the center, the larger the scale will be. So let's do absolute. Now it might actually, Wait. That doesn't seem right. Oh yeah, of course, because railpost normalizes the value between 0 and 1. So we need to do 0.5 minus. Now we have hourglass shape, but we want the opposite, so let's do that. So there we go. Let's add a fop attribute fop. Like usually I always use wrangle nodes, but for noise I make an exception because it's just easier to visualize, I think. And the nodes are easily controllable with parameters. So let's use a unified static inside the position, and we'll put the noise. Yeah, so let's use the displacement sub, not distance, displace along normal. And set it to P, I would say. Oh, yeah, there we go. This needs to be amount, of course. So this is not the type of noise that we want. Yeah, because right now it's Berlin noise, but we're actually going to use the new Chebyshev, which is new to 16.5. There we go. And now we actually need to make sure that we decrease the scale a little bit. So yeah, we can do that in here. Just say 0.5. No, that's not enough. Okay. Let's continue this in the next part, just to be sure that I can look up some stuff. See you in a moment.